and welcome to the practical part of today's lecture. Here I have a brand new Unity project where I'll be showing you how to set up unit testing, and we'll actually write some code ourselves. But most importantly, the thing we have to start off with is setting up the Unity test framework and making sure everything is referenced properly, because this is usually the thing that trips people up most the first time. First things first, we have to actually see if the Unity testing framework is installed and up to date. To do that, we go to Window, Package Manager. It's gonna see the packages that we have. And here we have to see Test Framework. For you, it probably will be, it probably will need an update, so you can go ahead and update that, but this is not something that should really matter. As long as it's installed, as long as you have Test Framework here, then that's good. Then we can actually go to the most visual part, so to say, of doing tests in Unity, and that's the Unity Test Runner. That is the little window, the interface item that helps us see our test and if they pass or not. So to do that, we go to Window, we go to General, and we find the Test Runner. This is it. You can attach it wherever you like. I'll just attach it here for now, so it's more visible. The first thing it's doing is that it's prompting us to create a test assembly folder, which we definitely will do, because that's one of the most important things. So let's go ahead and do that. I will call this editor. Now, maybe it's not necessarily important to name it editor, or in theory you should be able to name it whatever you want, but I found that Unity can be a little buggy. And so I name it editor just to be sure. It has problems sometimes. It shouldn't, but you know, it's Unity. It does its own thing. So here we go. We create editor, and it's already created. And if we go inside it, we can see it's already created an assembly definition. This is a thing that keeps our tests separate from our production code. And to really hammer that point home, we're also going to do this manually for our normal scripts. This is good practice to do in general, so you can separate your scripts properly, and even more so important when you're doing unit tests. So I'll just simply create a folder called scripts. In it, I will create a new assembly definition and call it scripts2. This is what we'll be referencing our gameplay scripts. And then I will link our scripts reference to our editor assembly reference. Here we go. Now our unit test can see all of these scripts that we put in the scripts folder. And this is very important to do. I'll save the import settings and everything. And now we can actually go to writing a unit test. But before we write a unit test, we need an actual code test. And so let's imagine that we have some sort of object, some sort of cube, so to say. And this is just something. It could be a character, it could be an enemy, it could be anything. But it's something that, for the sake of our test, it's something that has health and something that can die. So today we'll be writing a very basic function to disable this object once it's dead. To do that, we'll go to our scripts folder. We'll actually create our script. Call it very creatively cube. Sure. Thanks, Visual Studio. That's not exactly what I wanted, but here we are. Here is our script. As you can see, just created, pretty default. I'm gonna get rid of basically anything. I'll leave the update function for completeness sake. So as I explained before, in this imaginary scenario, in this game I'm making, I want this cube to have health, and I want it to die when that health is depleted. So I'll just start with a very simple variable, health, and we need something to disable the game object once it's dead. So I'll create a function I'll call it disable on death because that's a very descriptive name for it. It should disable the game object once it's dead, once the health is depleted. And of course, to check if the health is where I want it to be, I'll set it to check with an if statement. Pretty simple. This is how I would go about writing this normally. Game object.setActive false. Should be pretty straightforward. Once the health is less than 0, the game object is set to false. And to make this complete, we'll also call this function within the update loop. And so we're checking on every update if our health is less than 0. Makes sense. I think this is how dying should work in a game, maybe. And so this is our very simple behavior script for our cube character. However, we can't really see if this works. There's no way we can test right now if calling this function actually disables the object once the health is depleted. We could test this by maybe implementing some more code, maybe in the update function to check if we're pressing a button, and maybe that could remove health, or we can implement a combat system, or basically there's infinite other possibilities of things of code we could write to so we can interact with this function. But this all involves writing gameplay code. This involves adding complication and writing more things that we could write badly or could be broken. And we should be able to test if this very simple piece of code works just by itself. Because then what, we're gonna have to start programming things, and then especially as your project gets more complicated, what you're gonna go to Unity, you're gonna hit play, and then you're gonna like actually mess around with things to see if they work and how they work. That's absolutely ridiculous. You are going to miss things. There's no way you can comprehensively test like this, and you want to be able to test your smallest little pieces of code. That's the point of unit testing. So let's make our first unit test. That would involve us going back to the test runner, to our editor folder, and then we will create our first test script. Momentous occasion indeed. I'm gonna call it very creatively cube tests, because this is the class that tests our cube class, the class that contains the tests for our cube class. And let's open it up in Visual Studio. Let's reload the solution, of course. And here it is. It gives us like a bunch of default code, but we don't really need to mess around with any of this. We're going to be running a very simple test today. As we saw in the theoretical part of the lecture, our tests have to be designated with a test attribute. And then it's basically just like writing a normal function. So it'll be a public void. Now, to do our naming conventions properly, we first have to write the name of the method that we're testing. If you want a reference, we're testing the disable on death function. So that will be called disable on death. Then we have to say what situation we're putting this function in. In our cases, we are depleting the HP. So something like empty HP should suffice. And then what result should happen, and that is that the object should be set inactive. And this lets us know. Actually, if I save, I can show you that this lets us know here in the test runner exactly what the test is. Here, if I open it, we can see here it is exactly. So this test is testing for this function, putting it under this scenario, and it is expecting this result. And then this circle would turn into a check mark or a cross if it passes or fails. And then we know exactly where the problem is. But we have no code in our test yet, so let's not get ahead of ourselves. If we want to test this function, we first need to create a game object and attach this class to it. That's just how Unity works. So this is pretty trivial stuff. We'll make a game object, call it test object, because I'm very creative. because it doesn't have to be complicated. That's the thing with unit tests and generally programming. It doesn't have to be complicated. Just take things slow and step by step. It's the point of unit testing, to test your smallest single units. And then we'll actually create an instance of our script, of our cube script. And then we'll attach it to our test object. Add component. The syntax is always a bit wonky, but here we are. So we have created our test object. We have created our test cube essentially, and we have attached the cube behavior script to it. Now we actually have to perform the scenario we're putting it under. And in our case, that would be just emptying the health. So we'll just set the health to 0. And then we actually have to run the function we're testing. Let's not forget about that. That is an error I have made quite a few times before. I'm not afraid to admit it. Here we are. So we have created our object. We have put it under the scenario. And now we use the magic of the NUnit framework, which is the assert class. The assert class lets us compare things, lets us see. It has many different ways you could perform your test, but this is the thing that either checks true or false. This is the thing that checks if your test passes or not. It's not true or false, because you can also compare. You can compare a result from a function to an expected result. You can compare for game object. You can compare for true or false, of course. You can compare for things being equal. As you can see, there's a lot of things here that you can use. There is a full documentation on NUnit's website, and this can be as complicated as you want it, but luckily it can also be as simple as you want it. So today is going to be very simple. We're testing if something is false. Yeah, doesn't have to be complicated. And the thing that should be false is that the test object should be active. Active self. There we go. And so this boolean should be false because after setting the health to 0 and running this function, the test object should have deactivated because the function should have set its active state to false. Makes sense to me. Here we have our first unit test. Pretty simple, right? Now, let's go to Unity and run it. Here it is. We can select run all, or we can select run selected. We only have one, so it doesn't really matter. Save our scene first, that's important. And our test fails. How unfortunate. Expected false, but was true. So our object is still active despite setting the health to 0. Well, here we can do very simple debugging. We know the problem is with the health. So we can actually go and check our function. And we can see that we've set it that the health should be less than 0, but the scenario we're testing is when the health is 0. And by design, by the game design of this game that I have just imagined in my head, the enemy should also, not the enemy, the cube should also be dead when it's also equal to 0, not just less than 0. And so I caught myself making a pretty simple mistake here with this test. And so now I can go back to Unity. I can run our test again, and this time it passes. So that was a pretty simple behavior bug that I had that I solved very quickly without having to do any other additional gameplay code that could break other functions. And so I hope you can imagine that with more and more classes that you have, with more scripts, with more functions in them, just the complication of your code becomes so big that you really cannot track all of these things, and you might have problems that are much more complicated than, I forgot to put the equal sign. Okay, so while we do have our unit test and it works great, it does not guarantee that our function runs properly, because this that we have over here only tests if the object is set inactive when we put the health to 0. It doesn't test, for example, if the object stays active, but we still do some damage. It might be that any number of damage that we do, the object is set inactive. Maybe it's always inactive. And so we need to write at least one more test to properly cover this function. And that will be the situation where we do damage, but the whole thing is still alive. So in order to make my life easier, just copy the old one, and I will change what happens, of course. So we're still testing the same function, but in this situation, it still has HP. And the result, we want the object to remain active. This code is the same. However, instead of 0, we want it to be some sort of positive number. So let's do 20, for example. And then instead of testing for this to be false, we want to test for this to be true, because we want the active self to be true. We want the active state of the object to be true. We want it to be active. We don't want it to be dead. And so we can go back to Unity. We can run our additional test, and we can see it passes. If you want to be sure, we can run them all, and there we go. And we can see these tests run so fast that it basically runs instantly in 0 seconds. And this is what you want. Imagine that with a much larger project, we'll have hundreds, if not thousands of these tests, and it's really important that they all run very quickly, otherwise you'll be wasting time. It's still much faster than having to start the game and actually interact with it to see if your code works. That's the most time wasting thing. Of course, that's why you have QA, but this makes it easier for you, for QA, and for everything. Okay, so let's go back to our code, because we're not quite done. The first thing that strikes me as very nasty here is the way this code looks. We're essentially doing the exact same thing twice, so this is just bad code. We shouldn't be copy pasting stuff. This is just bad. And so here I want to use a great Visual Studio function. It's extract method. So Control R, Control RM. There we go. Control RM. Don't hold Control R for too long. It gives us it extracts this code to a new method. And in this case, I'll call it make fake cube, because what we're doing is we're making a cube, but a fake cube, because it's not in the game. It's just for the test. And then I can just have this line of code here. Much cleaner. And of course, these are tests, but this won't show up in the so this function won't show up in the Unity test runner, because it's not a test. It's not designated with the test attribute. It's just a function that helps our other tests. The problem we have here now is that both tests set the health to 20, so just make it pretty simple. Int, what is it gonna be? It's gonna be HP. Then we're gonna say health equals HP. And there we can put it as it was before. So it remains active on 20, and it has to die on 0. Now we can see if our very quick little coder refactoring worked. We can run our tests again. Everything works fine. So our refactoring was good. And now the final thing that's very useful to learn before you start writing your own unit tests is how to use test cases. Because while we do check for dead and alive, we only check really for 0 and for 20. There could be other values that behave differently. So we want to cover those cases. In this case, for example, we can add more test cases without actually copy pasting the whole function. That would be a nightmare if we had to. But luckily we have the test case attribute, and it's very simple. It lets us just put a value just like that. So this is our test for 0. And let's put a test for negative values. Why not? Maybe in our game your health is never supposed to go negative, but this function should operate the same no matter if it's negative or not. So this is a scenario that we need to cover with our test. And then the way we make it work with the test is to just put a little variable here. So here, if I save and I go back to Unity, here we are, we can see that there's a little arrow here. And now we can see our test cases. So this is our test, and we have 2 test cases here, when it's 0 and when it's -29. We can run the test cases and they all pass. Good. Under these conditions, our function works. But we also have to add some test cases for here, because maybe it behaves differently with positive numbers. So to make it easier for everyone, I'm just gonna copy them from my reference sheet. Here's the examples, and of course I need to also put the HP here. And I actually did a big mistake, because this should be HP instead of 0. It still ran for 0 in both cases. But it's a good thing I caught that. And so now everything works fine. Here I'm testing for a case where it's close to dead, but not quite, so it should still be alive. I'm testing for a float number. Maybe nothing is supposed to give, it's supposed to damage us in floats. Maybe it's all supposed to be integers, but there's no reason our function shouldn't handle this either. And then I'm testing for just full health, and I'm testing for an outrageously large number. Our function should pass in theory with all of these. So I save, and I go back to Unity. Here we have the rest of our tests here, and I'm just gonna say run all, because that's a lot of tests. And we can see that it passes on all of them except the float one. What does it say? Object type of system single can all be converted to int32. Huh. It seems like it's expecting an int. Very weird. I wonder why that would be. And so our test has already shown that there is some unexpected behavior within our cube code. And if you go back to the cube class, we can see, yes, our health is an integer, but we're trying to feed it a float value. And so a simple test here would be to just convert it to float. Or alternatively, we can have different ways of handling this, but this is the simplest solution I can show you here. And in this case, if I go back to Unity, there it is, and I run this test again, I see that it's broken again. And I have to give it a good think, and I see that, oh, duh, I changed this to float, whereas I should have changed it to float in every situation where a float should be expected. Now you should be making mistakes like these as a programmer, but it's a good thing that I caught it here while writing the unit test, instead of errors just popping up here and there during gameplay. So here we are. This has been fixed, and I should be able to now run this again, and it should pass. There we go. And that's it. We wrote 2 tests with a bunch of test cases each that fully cover the functionality of our dying function. And the more functions we have, the more tests we can write, and the more we can be sure that everything works properly. Tests are pretty awesome. So for a few closing words, I want to say that there's a lot more functionality to the Unity test framework. You can test more complicated things than just your very simple units of code, than just your methods. You can even create scenarios where, for example, if you have a character, you can put buffs on it, debuffs, different spells that you have. You can put your character in different scenarios and see how its character code behaves. You can see what the results of functions that you've added are based on others, but those are larger than unit tests. The point of doing this really small level unit testing is that it really helps to both understand your code, both while you're writing it and, 5 months down the line when you decide to revisit your project, or when you're giving it to someone else, or if you're working in a group, be it at school or with friends or in a professional setting, if you're working with other people. It helps for your group members to understand how things should work and if the changes they're making are affecting the rest of the code, and more likely not if, but how they are affecting and what they're breaking. It's much easier to track problems like this. And while the unit test framework can give you a lot more functionality with this, for you just to start off, you don't really need to go too complex. As you can see here, we wrote a very simple function and a very simple test for it. This is the sort of thing you can do in 5 to 10 minutes max. Sure, it took me 20 or 30 at this point, but if I wasn't talking and explaining, of course, they would have gone quicker. I have to reiterate that it's really important to write unit tests. If you don't, your code will get too bloated eventually, sooner or later. So it's really important that you do this for yourself, and especially if you're working with others. And stop it all off. This is a skill that is really highly valued when you are job seeking. If you want to work as a programmer, be it in game dev or in anything else, being familiar with unit testing can really push you ahead. It can make you competitive compared to a lot of other people who are also looking for jobs. So this was the basic introduction to unit testing. I hope this was clear enough, and I wish you all a great day.